All right, here we go. First video of two videos. This one's just going to talk about the nuts and bolts of doing a hypothesis test and what it means. And the next video is going to show you how to do it. Run through two full hypothesis tests. So here we go. When you're doing a hypothesis test, what you're doing is you're trying to test to see if you think that the mean is a true mean. So for example, let's say that you hypothesize that you have 150 text messages on average, or you average 150 text messages a day. And then, but you are kind of weary and you think that maybe you have more than 150. Well, your text messages per day are going to be kind of averaged out, right? 150 should be the center, right? And then sometimes in a week or in a day, you'll have like 160, sometimes you'll have 140, sometimes you'll have 200, right? So you're gonna test to see, do you have more than 150 text messages, right? So mu is gonna be the population mean. So this is always gonna be mu. Your hypotheses are always gonna talk about the population mean. And then what you're gonna do is you're gonna see if your sample mean is far enough from the population mean to say that this is probably not true, right? So mu is going to go in the center. And then x bar, that's going to be your statistic, right? And for like this one, let's say I had an x bar of like 175, right? So that would be like, x bar would be here, 175. And then you have to figure out, is that far enough away from the center to say that this is actually false? So the distance between this and this is called your z-score, right? So that's going to be the distance between mu and x bar, right? We talked about that a lot leading up into this chapter. The p-value is going to be the area under the curve from that z to the edge of the curve. So the p-value is the area under the curve from z to a tail. Right? So that's going to be the probability. Given this is true, it's going to be the probability that you actually got this. And the alpha value is what you can think about it as your rejection value. So an alpha value, what you do is if you have a curve, if it's one tail, it'll either be here or here. If it's two tails, it'll be evenly distributed between the two. But basically alpha is kind of the post. So if I do an alpha of 0.05, that means that 5% is the alpha. So if I get anything over here, I'm going to say that this probably didn't happen, that the mean probably didn't happen. And if I get a z anywhere in here, an x bar anywhere in here, that probably means that, well, okay, maybe it did happen, but we don't have enough information. So the alpha value is your fence post. If you get something past the alpha value or smaller than the alpha value, you're going to reject the null hypothesis in favor of the alternative. And if you get something bigger than the p-value, you're going to fail to reject. Right, so let's do a couple examples here. So here we got a z of 1.56 and we have an alpha of 0.05. So the problem is that this right now doesn't have a unit, and this is a percentage. So 0.05, and it's going to be a one tail. So 0.05 is right here. So we're going to do a calculation here, and we're going to see if this z-score, remember if it has a z-score of 0, it's right in the middle. We're going to see if this z-score is far enough from the mean, from 0, to be statistically significant. So we got to find the area under the curve. So we go invert norm, we go normal CDF, and we want 1.56 to something big. Let's do that real quick. So I'm going to go stat. I'm going to go, second distribution, normal CDF, 1.56 to our upper level, so we can call it 100 or 1,000 or whatever you want. Mu 0, standard deviation 1, we're going to see the probability of being this far away from the mean. So that's going to be 0.059. So if you notice, this right here is bigger than this right here. If this is bigger, if your area under the curve is bigger, that means that it was right about here. That's where my x bar was, right? The area is bigger than the alpha value, so 0.059 is bigger than the alpha value, 0.05, therefore, failed to reject. Okay, so if your p-value, that's what we just found, is bigger than the alpha, we fail to reject. If your p-value is less than your alpha, then we reject. Okay, let's try again. So again, we're doing a one-tail test. We have a z of negative 2.3. So now we got an alpha value of 0.01. So we're going to reject anything less than 0.01, and we're going to fail to reject anything more than 0.01. So let's do normal. CDF, negative 2.3. Ooh, we got to go from the small. So negative 100 to negative 2.3. Second distribution, normal CDF, negative 100, negative 2.3, 0.1. So we get a p-value of 0.0107. Dang, that's really close. So again, 0.0107, that's actually greater than 0.01. So this is my p, this is my alpha. Right, so again, p is bigger than your alpha, so I got a p-value probably right about here. That's bigger than your alpha, so again, we're going to fail to reject. I hope one of these we reject. Okay, here we go. So this one is a two-tail test. So this one's a little different. We got a two-tail test here, and our alpha level is 10%. So that means that between here and here, I need 10%. So my new alpha level is actually going to be 0.05 on either side, right? And then z is 1.97. So let's go normal CDF. We always want to go to the tail, so we're going to go 1.97, 100. Second distribution, 1.97, 100. We get 0.02. So this was our alpha value, 5%. We just got a p-value, probability of it happening given that the center is actually true, is about 2.4%. So because this 2.4% is less than 5%, so our p-value is less than our alpha value, we reject HO for HA. Last one. So again, we have two tails, so we're going to have to take our p and split it up between the two. So we got 0.025 here and 0.025 here, and we're doing from negative 2.5. So negative 2.5, we're going to start negative and big and go to negative 0.25. 2.5, excuse me. So second distribution, normal CDF, we'll find an area, negative 100, negative 2.5. Let's figure out what that p-value is, 0.006. So again, this number, our p-value is less than our alpha value, right? So we just got a p-value that's way down here in that shaded region, right? Here's our fence post. Anything beyond that fence post is statistically significant, meaning that we're going to reject HO. All right, cool. Next video, we'll do a couple different hypothesis tests. See you soon.